Hi everyone, today we are going to discuss about k-means clustering. Clustering is the classification of objects into different groups, or more precisely the partitioning of data sets into subsets. Simply, clustering is nothing but classification of similar group of objects into one cluster and dissimilar group of objects into another cluster. This means so that the data in each subset ideally share some common trait. Common trait is a feature or some distance. Based on some distance measures, we classify objects into clusters. Hence, here are types of clusters. Clustering can be solved using two types of algorithms, one using hierarchical algorithms and partitional clustering. Hierarchical algorithms are of two types. They are top-down approach and bottom-up approach. Bottom-up is also known as agglomerative. Here we begin with each element as a separate cluster and merge them into successively large clusters. Hence, top down is the opposite of bottom up. Here we begin with a whole data set and proceed to divide into successively small clusters. Hence, in partitional clustering, partitional algorithm determine all clusters at once. They include k-means and derivatives, fuzzy C-mean clustering, and QT clustering algorithms. Let's explore clustering. Hence, clustering can be done using common distance measures. Here are some common distance measures. Distance measure will determine how the similarity of two elements is calculated, and it will influence the shape of the clusters. They include Euclidean distance, Manhattan distance, maximum norm, Mahalan-Boyce distance, inner product space, and Hamming distance. Furthermore, we will discuss and use mostly Euclidean and Manhattan distance. Mostly we use Euclidean distance for two norm. Euclidean distance also called as two norm distance, where Manhattan distance is also called as taxicab norm or one norm. Here are the formulas for Euclidean distance, where d of x comma y equal to sigma of I equal to 1 to p mod of xi minus yi. Xi and yi are the data points of the clusters we are going to classify based on the distance, where Manhattan distance is used as used by the formula d of x comma y equal to square root of sigma equal to 1 to p mod xi minus yi whole square, where we will not discuss about this, but Hamming distance sometimes is also known as edit distance, measures the minimum number of substitution required to change one member into another. We most often use Euclidean and Manhattan distances other than these four. So next, k-means clustering is an algorithm to cluster n objects based on attributes into k partitions, where k less than n. Here in this algorithm, we will be given n objects based on attributes. We divide n objects into k partitions, where partition should be less than the given objects. It is similar to the expectation maximization algorithm for the mixture of Gaussian, in that they both attempt to find the centers of natural clusters in the data. It assumes that object attributes from form a vector space, where we use sum of squares criteria in this algorithm. An algorithm for partitioning or clustering n data points into k disjoint subsets containing data points so as to minimize the sum of squares criterion. We use this formula: j equal to sigma j equal to 1 to k, sigma n belongs to Sj. Sj is a subset and n is the data points, xn, where xn minus uj whole square. Here we see xn is the vector representing the nth data point of uj is the geometric centroid of data points in Sj. Simply speaking, k-means is an algorithm to classify or to group the objects based on attributes or features into k number of groups, where we usually assumes that k should be a positive integer. The grouping is done by minimizing the sum of squares, distances between data and corresponding cluster centroids. Let's see how the k-mean clustering algorithm works. We will be given a data set, so we need to first start and the number of clusters k. We will group uh, given data points into k clusters. Then we will find a new centroid for the clusters. We'll measure distant objects to centroids. Here we assume centroid based upon k value we have taken. By taking that k value, we will find the distance objects to centroid. We will find every object's distance from that centroid. Hence, after that, we will group based on minimum distances. If no object move group, we will end the process. If no object forms the group, we will to rotate this loop. We'll find again centroid and distances and we'll group them again. Let's see steps involved in k-means clustering. Begin with a decision on the value of k equal to number of clusters. So we need to take k value from the given data set. So we put any initial partition that classifies the data into k clusters. You may assign the training sample randomly or systematically as the following. Let's see the steps. Take the first k training sample as single element clusters. Assign each of the remaining n minus k training sample to the cluster with the nearest centroid. After each assignment, recompute the centroid of the gaining cluster. Once we will see the problem, you can understand the steps. See, in the next step, we'll take each sample in sequence and compute its distance from the centroid of each cluster. If a sample is not currently in the cluster with the closest centroid, switch the sample to the cluster and update the centroid of the cluster, gaining the new sample and the cluster losing the sample. Hence, after this step, we repeat step 3 until convergence is achieved. Means you find all the distances from the taken centroid, and that is until a pass through the training sample causes no new assignments. We'll see a problem, a simple problem to show the implementation of k-means algorithm. Here I am taking k value as 2 and this is the data set. K value 2 means we need to take two centroids. So we randomly choose two centroids from the given data set. So I am choosing 1 and 4. We will take the attributes of the taken object as the centroids. So I'll take m1 equal to variable 1 and variable 2 of first individual and m2 as 5 and 7 of the fourth individual. So we will group according to the centroids in the given example. In step 2, we will find centroids of each individual cluster. So the formula is m1 equal to this is 1 by 3. 1 by 3 means we will find the mean of the clusters. After all the finding, we will find Euclidean distance and centroids. We'll continuously update the centroids every time to obtain new clusters. After solving all these steps, we have two clusters, 1, 2, 3 as 1 and 4, 5, 6, 7 as 1. In step 3, now using these centroids, we compute the Euclidean distance of each object as shown in figure. See, using centroids, we group 1, 2 as one group and 3, 4, 5, 6, 7 individuals as another group. So next centroids are m1 equal to centroid can be find as taking the mean of 3 clusters, and we will take this point as the new centroid and m2 as new centroid for further steps, and these are calculated using Manhattan distance. Now the next we update the next centroids as m1 and m2. In step 4 we can clearly get the clusters as 1 2 as one cluster and 3 4 5 6 7 as another cluster. Therefore there is no change in the clusters, thus the algorithm comes to a halt. We will stop this finding the centroid new centroids at this point, and we will have the two clusters as 1 2 as one cluster and 3 4 5 6 7 individuals as another cluster. If we'll plot these points according to the centroids and values in this, and we will group data points as this. What happens if the k value increases? So let's see that also. We will take 3 points as centroids. So I am choosing initial centroids as 1 2 3, 1 and 2 and 3. In step 2 we will continuously update the centroids and we will get the distances from the particular point to the centroid, and we will update this table to get the clusters. Here see, when the k value increases, 1 belongs to one cluster, no change, but 2 belongs to the second cluster. So and 3 4 5 6 7 into the third cluster. Hence when we take k equal to 2, we grouped 1 2 as one cluster and 3 4 5 6 7 as another cluster. When the k value increases, we are observing that 1 belongs to first cluster, 2 belongs to second cluster, and 3 4 5 6 7 into third cluster. So here you need to observe that when the k value changes, the assignment of objects into clusters also changes. So we plot according to these points using axis. So thank you.